Hello everyone. In this class, we will introduce mode isolation device. The effect of mode isolation device are as follows. First, the inner wall is well lubricated to prevent the bonding between the primary shell and the inner wall of the mode. Second, the isolation are helpful to improve the surface quality of the slab and form the slab with smooth surface. Third, when the bond occurs, the isolation can force the demolding and eliminate the bond. Fourth, when the shell in the mold is broken, the pressing is obtained by the synchronous isolation of the mold and the billet. To the requirement of the mold isolation device. The first, the isolation device shall move in strict accordance with the required isolation curve. The four corner positions of the whole isolation frame shall rise to the top dead center or descend to the bottom dead center at the same time. During the isolation, it is not allowed to shift and shake in front and back, left and right directions. The second, the isolation device shall be stable, soft, and elastic during isolation. The third, the equipment is easy to manufacture, install, and maintain. To the mold isolation mode, according to the characteristics of the mold isolation speed, it can be divided into three types. First, synchronous isolation. Second, negative strip isolation. Third, sinusoidal isolation. The isolation curve is shown in the figure, which is mainly reflected by the change between mold movement speed and time. First, synchronous isolation. Synchronous isolation is the earliest isolation mode. When the isolation device is working, the mold moves synchronously with the billet when it falls. And then, the mold rises at 3 times of the casting speed. When the mold changes from falling to rising, the acceleration is very large. This will cause impact force and affect the stability of the mold. Second is negative strip isolation. Negative strip isolation is an improved form of synchronous isolation. When working, the mold first drops at a speed slightly higher than the casting speed, called negative strip, which is conducive to forced demolding and pressing of broken shell, and then rises at high speed. It is beneficial to the stability of isolation and the thickening of billet shell. But a cycle mechanism is needed, and interlock between isolation mechanism and billet drawing mechanism must be ensured. The third is sinusoidal isolation. The relationship between isolation speed and time is a sine curve. The time of sinusoidal isolation is equal, and maximum isolation speed of up and down is the same. In the whole isolation circle, there is always relative movement between the slab and the mold. And in the process of mold falling, there is a small section of the falling speed which is faster than the drawing speed. So, it can prevent and eliminate the bond between the slab shell and the inner wall of the mold. It can play a healing role for the slab shell, which is pulled and cracked. In addition, since the velocity of the mold changes according to the sine principle, the acceleration must change according to the cosine principle. So, the transition is relatively stable and impact is small. Sinusoidal isolation can be realized by eccentric wheel linkage mechanism. It can improve the isolation frequency, reduce the isolation mark, and improve the quality of slab. So, sinusoidal isolation is widely used. The next is non-sinusoidal isolation. The fourth, non-sinusoidal isolation. The non-sinusoidal isolation has the following characteristics: short negative strip time, long positive strip time, small difference between the mold upwards velocity and slab velocity. In use, it has the effect of little change in the surface quality of the billet, low leakage rate, and stable operation of the equipment. Now, let me introduce mold isolation parameters. The isolation parameters of the mold refer to amplitude, frequency, negative strip time, etc. First, amplitude. The distance the mold moves from the horizontal position to the highest or lowest position. Expressed as S. Its unit is mm. Second is isolation frequency. It means frequency of the mold isolation per minute. Expressed as F. Its unit is time per minute. Third, negative strip time. The negative strip of the mold isolation device means that when the isolation speed of the mold drop is greater than the speed of drawing billet, the billet moves in opposite direction to that of drawing billet. The negative strip time is the time of negative strip for each vibration. With the development of continuous cutting technology, the application frequency of the mold is increasing constantly. At present, the mold of small amplitude and high frequency is mainly used. Nowadays, the frequency of 0 to 250 times per minute is used. The isolation amplitude is small. The liquid level of fluctuation of the mold steel is small, and the surface isolation mark of the billet is small. The longer the negative strip time is, the deeper the isolation mark depth is, and the higher the probability of transverse crack is. Next is mold isolation mechanism. The isolation mechanism of the mold is a device that makes the mold isolate in a certain way, and its function is to make mold isolate regularly. Commonly used isolation mechanisms are short-arm 4-bar isolation mechanism, 4-cam isolation mechanism, and hydraulic isolation mechanism. First is short-arm 4-bar isolation mechanism. Short-arm 4-bar isolation mechanism is widely used in small billet and large slab caster. But the isolation mechanism of small billet caster is mostly installed on the inner arc side, while the isolation mechanism of large slab caster is installed on the outer arc side. The structure of the short-arm 4-bar isolation mechanism is simple and easy to maintain. It can realize the arc movement of the mold accurately and improve the quality of casting billet. This is 4-bar isolation mechanism for the billet caster. The isolation mechanism for the small billet caster is mostly installed on the inner arc side. This is the fallback isolation mechanism for slab caster. The isolation mechanism of large slab caster is installed on the outer arc side. Next, we will introduce four-cam isolation mechanism. Four-cam isolation mechanism still belongs to the sinusoidal isolation. The advantages of the four-cam isolation mechanism are: the mode isolation is stable, no swaying and jamming phenomenon, suitable for the application of high frequency and small amplitude technology, but the structure is complex. Next is mode hydraulic isolation mechanism. Using hydraulic system as isolation source, it has the characteristic of high control accuracy, flexible adjustment, small volume of equipment, lightweight, and small maintenance. It can not only meet the requirements of high-frequency isolation, but also eliminate the problem of motor burning and reducer damage caused by impact load in the transmission of motor and reducer. What's more, it can arbitrarily change the isolation waveform according to the process requirements, control the negative strip speed and time, improve the lubrication and the demolding between the mold and continuous casting slab, and reduce the steel leakage accident. At the same time, it can reduce the isolation frequency and the condition of high casting speed and mechanism wear. That's all for today. See you next time.